Good.
My name is Don Perry.
I'm Joseph Chalk.
I'm Larkin Lynch.
And I'm Caroline Mackey.
And we did the extension on heat and calories, finding the specific heat of an unknown metal. The objectives of this extension were to study how heat moves between materials in different phases and to find the specific heat value for an unknown metal.
Alright. So to give a brief overview, we took silver, aluminum, and titanium, and using the simulation heat and calories, finding the specific heat of an unknown metal, we were able to observe those changes and then apply it to find an unknown metal. So, as I said before, we were able to observe the change in temperature after the metal was added, and then we were able to calculate the change in heat, or the delta T. Alright, so this is what the simulation looked like before. We had the metal mass, the temperature, the water mass, and the temperature. And in the second one, the piece of metal was moved to the second glass. As you can see, everything is the same except for the temperature, which has changed from 73.92 to 71.97. So that was a change of 1.95 degrees Celsius.
Alright, so just analyzing the heat loss and gained by the metal and the water. So in these trials, since the mass of the metal was much less than the mass of the water, the metal gained much more heat than the water lost. And in an ideal situation, where the mass of the water and the metal were equal, these values of heat loss / gain would be equal. Also, different phases would matter because solids take much more time to absorb heat than liquids do. And this is just a slide about the equation we use and the calculations. So the equation we use is heat equals mass times specific heat times delta T. So for the change in heat for the warm water, the value is negative 516.745, and for the metal, it was positive 511.835 joules, and the warm water was negative because it lost heat, and the metal was positive because it gained heat.
So also in this lab, we were tasked with finding the specific heat of each metal. And to calculate this, we used the equation of the change in temperature of the metal times the mass of the metal times X, our unknown specific heat, times the change in temperature of water times the mass of water times the specific heat of water, which is 4.18 joules per gram Celsius. And we solve for X, and X is the specific heat of the metal.